Okay, today we're going to talk about the origin of species. Not only is The Origin of Species a book that Charles Darwin wrote, but it's a topic that we're going to talk about in evolution. So, we're going to describe a couple ways on how new species are able to originate. And so let's talk about macroevolution. Now, we've already discussed this topic a little bit earlier, but we're going to bring it back. Now, with macroevolution, when we talk about geologic time, this is over a large chunk of geologic time. It's one of the main topics of how species were able to arise. We have many complex structures that evolve in many different stages. It wasn't just a boom, oh yeah, multicellularity. That didn't happen overnight. And so they know that with macroevolution that we have this thing called speciation occurring. It's a process where new species are able to evolve. Now, how does this happen? So basically with speciation, a species or a group of organisms can interbreed. Like humans can breed with humans to make more humans. What we can see with this is usually we're going to have a geographic separation. So an example of this would be we have a river. The river has separated two species of mice. They're no longer able to come in contact with each other. Well, it's the same species. They've no longer been able to come in contact with each other. And then all of a sudden, the river is gone a million years later. And these mice start to interact again. But they don't see each other as the same species of mice. They don't interbreed anymore. They no longer look at each other. And so that would be a separate species of organisms. And so we know that reproductive isolation is one way that we can make new species. But in macroevolution, we're just seeing these slight changes over time. Geographic isolation is just one way to explain how macroevolution occurs. The other way is allotropic speciation. And this is where a population is geographically divided. New species often arise this way. And so this is, again, part of your macro. But speciation, in this case, we have two little beautiful chipmunks in the Grand Canyon. These are DNA, two separate chipmunks. However, they're so different that when they see each other come in contact, even though they're little chipmunks, they will not interbreed with one another. And so we know that this is a new species because they will no longer interbreed with one another. If they'll still come in contact after this geographic isolation and still breed to have babies, they're not new species. You have to have a separation. Not only you can see that the two chipmunks are completely different, but in order for a new species to come or speciation to happen, you have to see no interbreeding anymore. Or if they do breed, their offspring isn't viable. So what does that mean to be not viable? It means either the offspring isn't going to live, or the offspring is going to be sterile. Now, the offspring might live, but it might not live for very long. Again, not viable. It's not able to produce offspring on its own. And so that's what we're looking for when we talk about a brand new species. So, let's go on to the next one. Sympatric speciation. When new species arise without this geographic isolation. So there isn't this river that just suddenly appears here. So we know that some type of flies will lay their eggs in trees. These eggs hatch, the larvae will feed on different types of fruit or whatever berries are in the tree. And so we see that we can have these flies start to evolve based on the location of where the tree is at. Also, if something happens to the tree where it's not producing the same amount of fruit. So when we see these flies that were there, what would happen if we introduce them to a new tree? Well, if we introduce them to a new tree, their larvae may start to feed on this new type of fruit, and therefore they might change that way based on the fruit that they have. And so that is another type of